So hi everyone. Today I will be giving a talk on real-time events using server-side event. And before getting started, let me give some introduction about myself. So I am Hervinder Singh. Currently, I'm working as a front-end developer with VMware, and so you can connect on with me on some social media account, LinkedIn and Twitter for further. Uh, let's get started. So I wanted to start with the real world use cases where exactly the server side event fits in our day-to-day use cases. Uh, let me start with you. How many of you, use see cricket information on Crick Info you use, or for football matches? How many of you use web pages to see the scores over there? Many of us, right? How many of you use Twitter in day to day and see their updates getting refreshed in real time? So these are some of the use cases I will be going to talk about today. That how these use cases we're gonna achieve through server side event. So I hope you get some context, where we're heading towards. So while you are give an example on the web page, while you are seeing some score updates on the web page, you have seen that the score gets updated in real time. You don't have to refresh the page in order to get the updated scores over there. You just see the screen and it gets automatically get updated in the background. And if you see, that's very fascinating to see, how everything is working in the background. It's automatically gets syncing up on the page. So this is exactly where the server side event fits in, and we will be talking further about how this we're gonna achieve the same uh, uh, technology to get the real-time updates over here. So let me give you some introduction about the server side event. So server side event is the server push notification, which helps the server to send automatic updates to the client. And once the connection is established, so the server can send the updates to the client at any time interval. So you don't have to wait for the client to initiate the request that give me some data. Then only the server respond. And so exactly the server side event fits that use case. I will be deep diving more into this use cases. First, let me can anybody help here? Sit. Yeah, Kiran. Yeah, this is the laptop. Yeah, no, this is mine.
Oh, okay. Akash's laptop is there to correct it actually. Okay.
Okay, it's fine. Uh, this is. Can you do a full screen? Thanks. So before jumping deep dive into the server side event, I wanted to step back and see how exactly the data sharing has been, working over the internet, and how the traditional approach was, and how it get evolved with the upcoming days, and how we achieve to the real time events, and what are the technologies we have in our industry right now. And but I want to set some context before that, how usually the traditional way of data sharing work. So if you see here, the traditional way, it's all started with the client and server request and response model. So on the left hand side, you can see the client, and on the right hand side, you can see the server. So in order to send so at the first time, the client sends a simple plain HTTP request to the server, and based on the request, the server respond uh, uh, with the data, if it has data right away, or with the empty response to the client, and the connection get closed. All this communication used to work on HTTP protocol, which is a stateless protocol, which means that in order for the client to again communicate, it again has to establish a new connection. So you can see on the second request, if the client again has to talk to the server, he has to again make another request, and based on that, the server will respond. So this used to be the model for web application, which usually fits for the use cases where you don't rely on the real-time events, and you need a data per basis of the demand. But this model doesn't usually fit with the use cases where you need a real-time events, where you have a streaming of events, and you wanted to use this technology to fulfill that use case. And for that, there are some of the options come up with the previously and now. So these are the four options I will be talking about. The four option is the HTTP short pooling, then HTTP long pooling, then WebSocket, and server-side event. So I will be covering each and every one, how exactly it works and where exactly this use cases fits in, and why we going forward with the server-side event. Yeah. Coming with the short pooling. So how many of you heard about the short pooling and exactly it works? So yeah, one hand. Two hand. Okay, no problem. So I will be telling. So short pooling is a Zax-based call which call itself at the fixed time interval. So what exactly is, on the left hand side is the client and on the right hand side is the server. You can see. So first of all, if client has to communicate to the server, it will send a plain request and the server responding two-way. Uh, if if the data is available, it automatically will respond back and close the connection, and the client will wait for a set time interval, and then again after the set time interval, it again will send the another request. Then again the server will respond, then again the client will wait for sub set time interval, and again the same format of communication will work. So if you see, the client uh, is waiting for some set interval before communicating to the server. So if you see uh, real-time event through this eyes, yeah, you will somewhat will achieve the updates. You are, if I'm talking about the updates of score updates, um, I say after every 1 minute, go and fetch the updates of the score, latest update. So I'm using a simple model, and so what this short pooling will does, after every 1 minute, it will go and fetch the latest data from the server, and this is working over a simple plain HTTP protocol. This used to fulfill some of the use cases, but it has all comes with its own challenge. So the one of the advantage of this technology was it is simpler, and because it works over the simple HTTP protocol, you don't have to do any configuration on the server or a client. It works on the normal call. And the second is that if your time, if your events are taking in between, if your the time between your events happening is too large, if I say about 5 minutes, your events are coming between the span of 5 minutes, and then you can use this short polling, which is a traditional way, that after 5 minutes you can call and fetch the data. Uh, that will somewhat not be a server consuming, but it's a very plain technology if your use cases somewhat fits that application. But Kiran, can you? Okay. Yeah, we can continue. So coming to the cons, we can right away see from the approach also that we are end up making a too many requests after each interval, and it's not sure that every time we are getting the data from the server. Sometimes it happens that you are making a call to the server and data is not there. Then the server is responding with a plain stale response. So it usually not a best case scenario over there, that if you're you know if your events are happening at not a time interval where you end up making a too many requests to the server, and you end up getting a not consuming the response format over there. Second thing is, if your application is somewhat where you require a very low latency, or with a you want an event where you don't need any delay in timing whenever there is a event happening on the back end, you wanted to push it to the client as soon as possible. And you can see this, you are fetching the records from the server after time interval. So that puts not a very good idea to go forward with that type of application where you needed a low latency of timing over there. So uh, so the another approach was come with the long pulling. So long pulling somewhat helps. One of the use cases where the short pulling was has a disadvantage, that the server was giving a stale response even when the event was not there. So how exactly the long pulling works? So the client make a request to the server, and the server respond in two way. If the data is available, it will automatically respond back to the client and close the connection. If the data is not available, it will hold that request, persist that request for some time interval till the event is happening. And once after some time the event come, then the server will respond back with the response. So with this use case, your chances of getting a stale response somewhat reduces in terms of short pulling. And uh, and again the client again makes another connection. So here comes that, how long the server persists that request. It always sometimes depends that if the data is available, it respond back, and the client can make another connection. But sometimes you have to put a timeout on the API request format from the client, that if you don't get the response from that time interval, just time out the request and make the another call to the server. So this somewhat gives some advantage over the short pulling. One is the it's better than the latency and the getting a stale response um, from the short pulling. And second is that is simple implementation of HTTP protocol. And again the cons which comes over it, you can't use it for the system where your system require again with no delay and low latency. So this use case doesn't really scale over there. Second con is that if your if your application and machine is too complex, you end up making thousands of requests on alive with the server. And that will make a server resource not in a very pretty good state. You end up making a constraint on resources, on server resources. So this were some of the challenges, and which used to come up with the long pulling and short pulling. And based on that, then the another technology come, which is the WebSocket, which is how many of you heard about the WebSocket? I know many of us, because we are in the new area and we heard about the WebSockets. Short pulling and long pulling used to do with the traditional way. There are some use cases which industry used to follow that, but I think we very much aware with the WebSocket. So what exactly is the WebSocket? So WebSocket is the communication protocol which establish a bidirectional flow between client and server. And once the connection has been established, both the client and server can communicate with each other at any time interval. So you don't have to wait for either of the client to get some action, then only the server will respond. Once the pipeline has been set up, the both client and server can communicate over there. So uh, but how exactly this WebSocket works? So first the client make a simple HTTP call, and it uses HTTP upgrade protocol to upgrade the existing protocol, HTTP protocol, to the WebSocket protocol. So how exactly it works? Initially the client will initiate the HTTP protocol and ask the server to upgrade the from existing HTTP protocol to WebSocket protocol. So HTTP protocol usually works over the transport layer, and after the upgradation, this WebSocket usually work on the network layer. So yeah, you can just so I will continue. So once this connection has been established, the both client and the server can pipeline में they can communicate at any time interval. And this WebSocket usually work really well for the system where you need a low latency and both bidirectional flow of data you needed. So if talking about the game, in the gaming application, where you both the client and the user, while interacting with the game, they are playing it. So you needed an interaction, you are playing with the game, and you needed a response there, someone is also responding over there. In that type of use cases, WebSocket fits really well. that you needed a bidirectional low latency, and this type of communication really scale with that type of application. So if I talk about the pros, there are many pros. If your requirement is that you needed a bidirectional flow of data and low latency and less resources, is that WebSocket works over a single TCP connection. You makes once it's been connected, it works over a single TCP connection, and you can interact with both the client and server. The cone which I see is the implementation part of WebSocket. If your system has, is very complex and you end up making too many changes on the config side, so the load balancing over the WebSocket is complex, is achievable, but it's a task. So it's not easy to makes that type of configuration on all the level of the system. Firewall also face the same challenge in terms of WebSocket, because you are upgrading the existing protocol, HTTP protocol, to the new protocol of WebSocket. So, and the second is the cone, which is I see is that uh, taking a scenario of client and server, they both are communicating, and somewhat due to the network issue, the network get dropped and your connection get lost. So in that case, there will be no automatic reestablishment of connection, that the server will be, the WebSocket will take care that the connection has been dropped, I have to reinitiate and make a connection. In that case, you have to the client should be aware that the connection has been dropped. The client had to initiate again for the connection, and that's the one of the cones for WebSocket. And so with this challenge, we come to the ServerSent event, which is the our topic, where ServerSent exactly fits. So ServerSent is, I think, fits in a really wide range of applications, which we have talked about. If you have application where you needed a one direction flow, so ServerSent event is a push notification technology which allow a one direction flow of data. So you can see only the server is sending the events to the client. So if your use case is that where you need a one direction of data and latency is low, and there the server side event really scale very well. So how exactly works? It works over a simple HTTP protocol. So you, on the left hand side, the client make a initial HTTP call to make a connection request. It usually works over the event source API, which usually initiate. And once the connection has been established between client and server, at any time interval, the server can send the event to the client, and the client can respond and subscribe to that event. And based on that events, the client can take an action. And suppose our give an example of crickets. In the cricket, as a client, I'm not taking any action. I'm just taking the events from the server. So it's a one directional flow from server to the client. So in that use cases, this really well. And for one of my application also, where you have a uh, you know the progress bar, or some of the bulk operations you have to make in the system, and you have to notify the user with the time, how much the percentage of that bulk operation has been achieved. So some of that use cases really scale well with server side event. So, and you can close the connection based on either the client or the server initiative. So as we talked about, there are many uh, pros which I see in server side event. First is the lightweight and easy to implement, and if you have and it really work for the one direction from server to client. Low latency is the another one, and third one is the automatic reestablishment of connection. So this is also the one of the great point in comparison to WebSocket, that if somehow the connection get lost in between, this server side event will automatically take care of automatic reconnection, and it will take care of the automatic reconnection. It will again reinitiate and try to establish the pipeline again. And yeah, okay. Yeah. So the other point I've really talked about, that it's easy to implement as it's working on the plain HTTP protocol. So you don't have to make any higher level config changes on the firewall or the load balancer. It's a plain HTTP protocol we are using. You can use the same protocol to work around it, and you can establish that pipeline. the only con which I see with the server-side event is with the system which are working on HTTP1. So what challenge it has for how many of you know that HTTP1 there is how many maximum number of connection a browser can make on HTTP1? See. But it's usually a 6 around. So and the problem with this is if you're using server-side event with that, you end up making one permanent connection on one tab with the server-side event. And suppose your user end up opening 6 tabs, you consumed all the connection. But in that case, you can yeah, you can take some idea around it how you can optimize the tabs that you end up not making 6 connection in the 6 tab. But it's not usually a good idea to go forward with the HTTP1, because even if you are not scaling the tabs, your one connection will always be occupied with a server side event. So if yeah, you can make that optimization that in one tab you make a connection and another tab can listen to that. So but there will always be a one tab which will having a one connection which will be consuming one of the connections for the concurrent request, and the 5 you can use it. But the point is, if you have HTTP2, then with multiplexing there are 100 concurrent requests you can make, and for that use case this server side event really scale. So yeah, if anybody has question, then we can take it, and I will show the demo. Yeah. So is there any acknowledgement takes place between the client and server whenever server sends an event? So you know, like this is one directional data flow. So is there any acknowledgement from the client that yeah, I received the data? Because yeah, the server should know, right, whether client actually received the data or not. Yeah, there's a I will show you the code also. There's a subscription which happens. So initially there's a event source. So underneath it uses a event source API, JavaScript event source API. That event source API build a connection with the server, and the client will subscribe to that events. So once the subscription happens, whatever the event is coming on that stream pipeline, the client, that subscription will automatically be triggered from the client. I will show you on the code how it works. Yeah. Yeah, it's depend upon the if you're listening to particular event or not. Yeah, on the basis of that you can. Yeah. 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 What are you saying? Yeah, what? Is it TCP based or UDP based? Yeah, this is TCP based because HTTP is working on HTTP. Yeah. So I think it's acknowledgement. Okay, sorry if I take it in. Yeah, it's worked with a simple acknowledgement. Yeah, I thought he's talking about the events to be subscription or not. Yeah, it's exactly works like that only. But it's not like it's advantage over WebSocket or this WebSocket fill its own area of use cases, and server side event fills its own area of use cases. No, yeah, that's the point. If because chat application is bidirectional. It's yeah. Yeah.
still available. SSE is not. Yeah. Okay. Still available, and as and when the data comes in the body, the event is constructed at the client side. Oh, okay. Okay. So the HTTP is not ended.
I think you will get a clear idea once I will show you the demo. Kiran? Uh, so this is a very simple example I'm taking, which is I have a one file uploader, a function over here where I will upload a file, and there's a progress bar where once the file will uploading on the server, it will respond what is the percentage of it's been completed. So this graphical view will track how many percentage will be, and this percentage we will be getting through server-side event. So that's the use case I will be talking about. So I'm just uploading some file and just see the network over here. So how many of you see the this pipeline and how it is responding? So what exactly is happening over here? So once the file has been uploaded, I open the server-side event connection, and it usually works with the event streaming type, and it keep that alive connection. And this is the event stream, which is the type. In this event stream, you will get all the events which the server is pushing, and you can find there's a ID, there's a type, then the data and the timing. So ID will be unique. The type will be the type of event the client will be subscribing to. So there can be different type of events can be happen, and the server can be pushed different type of events over here. The client which the particular type of event which the client subscribe, it only gets those. So I'm subscribing to the file upload type. Then based on that, I'm getting the data. So you can see it first it was 30%, then 50, the 70 and 100. So you can see this, it was the same connection. In the same connection, I'm getting all the stream of events, and based on an event, I'm just showing over there. So, and if you see, this is this is the content type of event stream type, and works over the simple HTTP call. And yeah, this is the plain lightweight use case you can come across, and based on that, you can solve different use cases for your different application. I hope this example set some context where it is exactly we can use it. Yeah, I think this is a pretty small example, but it gives you a hint that you can go back and see how exactly you can explore more about the server-side event. Yeah, if not, then we can have a Q&A here.